Hi, in this video, I'm looking at this problem here where we're trying to determine how many integers are not multiples of 2 or 3 in the range of 1 to 50 inclusive. So with this problem, we've got the numbers from 1 all the way up to 50, including those numbers, and we want to know how many of them are not multiples of 2 or 3. So remember, our multiples are the numbers obtained from multiplying this number by our counting numbers, say 1, 2, 3, 4, 5. So for example, if we look at the multiples of 2, well then 2 times 1 is 2, 2 times 2 is 4, 2 times 3 is 6, and so on. It's basically counting in twos, 2, 4, 6, 8, 10, 12, and so forth. And our multiples of 3 are going to be the same, but just doing it with 3. So we got 3, 6, 9, 12, 18, and so on. So we want to know from the numbers 1 to 50, how many of the numbers do not appear on either of these lists. And that would be quite a complex thing to work out, because we have to work out what are all the numbers that are not multiples of 2, and then what are all the numbers that are not multiples of 3. And mathematically, that's a little bit harder. So we're actually going to flip this on its head and first work out how many are between 1 to 50. So how many are multiples of 1 and 2, of 2 and 3, sorry, that are in the 1 and 50. So to do this, let's have a look at how many numbers would be in this list. That's basically what I need to know. What would be the grand total of the numbers from 1 to 50? How many are in here? Well, easiest way to do this is take our biggest number, 50, and divide it by our multiple. And we're going to get an answer of 25. Because 50, counting up every second number, we're going to get 25 numbers in there. So if we let this be set A, so the number of items in A is going to be 25. And if we have a look at our second set, set B, let's call our multiples of 3B set B, then if we do 50 divided by 3, now doing this we're going to get a decimal. We're going to get 16.66 recurring, 67, but we're just going to round that down because otherwise we're going to count up too many. So our number of items in set B are going to be 16. Now we're setting this up as sets helps us think about what's going on, because we do have an issue with the numbers that we've counted. If I just go, well, all of the multiples of 2 plus all the multiples of 3 added up will tell us how many are between 1 and 50, I'm going to be double counting. Because if I look at these lists, I've got 6 turns up twice, 12 turns up twice, and if we keep on going with this, I've even missed out 15 in here, our next one that'll turn up twice will be 18. And then after that, we're going to keep getting more and more duplicates. So we're going to need to find out how many are in both sets. And the reason for this, if I have a think about this off to the side, I've got my multiples of 2 set A that I've counted up. There's 25 numbers in there. Well, in the entire circle, there's 25 numbers in there. And I'm going to represent this as a Venn diagram. So then if I have a look at set B, I've got 16 numbers in here. But as I said, I've got some duplicates in the middle, and I'm going to need to know how many are in here, because I've got 25 in this entire blue circle. So if I shade in the whole blue circle, there's 25 numbers I've just shaded in there. And then if I shade in my purple circle, I might just use a different color for ease. If I shade in my other circle, I've got 16 numbers in here, but I've counted this bit in the middle twice. So what I'm trying to find effectively is we want to know how many are in set A or in set B, but this means I need to know how many are in set A plus how many are in set B minus of how many are in both sets. So I've worked out set A, that was 25, and set B was 16. I need to know this amount because I've counted twice by adding up the first two. So let's have a look at how we would work that out. How many times do we get them turning up in both lists? Now, if we look at our first instance, we have the number 6. And if you think about it, any number that is a multiple of both 2 and 3 is going to be a multiple of 6 because we're going to have 2 times by 3 in there equaling 6. So when we're trying to find our last remaining set, when we're trying to find this A and B, how many are in both, I want to do 50 divided by 6. And if I have a look at 50 divided by 6, we're going to get 8.33. And again, round down because otherwise we'll count up one more than we need. So we have 8. So now, to get my answer of how many is in A or B, how many are multiples of 2, or how many are multiples of 3, I'm going to have my 25 that are in A, my 16 that are in B, but because I've double counted some numbers, I've got a minus of my double count. And so now if I work that out, we're going to get 33 numbers that are multiples of 2 or 3, but not double counting the ones that are both. Now that wasn't our question though. I want to know how many are not multiples of 2 or 3. That was what we were asked at the beginning. How many are not multiples of 2 or 3? So I want to know if I have A or B knotted. I'm going to put it in brackets, put a not mark after it. How many are in there? Well, because I know how many are, I've just got to work out how many I've got in total minus of how many are in A or B, and I'll have my answer. Now, how many I've got in total? Well, I've got the numbers 1 to 50 inclusive. So I've got all of my numbers from 1 to 50, which means that I've got 50 minus away our 33 that we've just worked out are meeting my case. And so how many are not meeting is going to be, well, 50 minus 33 is going to be 17. So there are 17 numbers that are not in A or B. So by working through the problem, using a bit of set notation, a bit set theory, we can work out how many things are in a set. But if we're chasing how many are not in our set, we've got to work out what's the grand total minus of the bit that we've just worked out, and that'll tell us the not case.